Hey guys, and welcome back to Quantic Academy. So today we will be talking about particle accelerators. Okay, so why do we accelerate particles? What's the purpose? Well, when we accelerate particles, we increase its speed. Okay, if we increase the speed, its kinetic energy increases, right? Half mv squared. So when you accelerate a particle, you give it more energy. And if you give it more energy, then you can collide it. Now, why do you want to collide particles? Well, think of it as colliding two trucks. When you collide two trucks at very, very high energy, what happens? The two trucks basically explodes and all its interior spurts out. So, we can do the same with particles. If we collide two particles at high speeds, then we can split the particle and see what's inside it, or we can create new particles. And the latter is a bit more complicated, but yeah, basically we can study what's inside the particles and quantum physics in general. Okay, so how do we accelerate particles? Well, how do you accelerate something? Remember, acceleration is a force. Acceleration requires a force. Force equals mass times acceleration. So we just need to put a force on the particle. How do we put a force on the particle? Well, if the particle is charged, then we can easily exert an electrostatic force. And that's done easily. All I gotta do is just create an electric field. Okay, if I create an electric field, then there'll be a force on the charged particle. And in this case, this particle is an electron, so it will move in the opposite direction to the electric field, and so the force on the particle will be here. So it'll accelerate this way, okay? So we can accelerate a particle by using an electric field. And so that's the main principle behind a particle accelerator. Just create an electric field. So if I create an electric field by having two parallel plates, one positive, one negative, I create an electric field due to the potential difference. Okay, there's a potential difference here because one side's positive, one side's negative, and that creates an electric field. But the thing is, right, if I have one plate on one side, another plate on the other side, and I want to accelerate the particle, then I'm going to have a really, really high PD to give it lots of energy, right? What I can do instead is I can have many smaller plates instead of having one big plate. And each of these smaller plates I can have potential difference of V. Now, I will accelerate across the potential difference many times. Remember, each time it accelerates across the potential difference, it gains energy, right? Because there's a force. Force does work, right? Work is force times distance, so it gives energy. And the work done is equal to charge times potential difference, because potential difference is equals to work done per unit charge. So work done is charge times potential difference, okay? And so if I go through the same potential difference many times, and instead of one time like in here, then the total energy gain will be much higher, because each time I'll gain QV units of energy. But if I do it many times, I'll gain it many times. So I'll gain much more energy, basically. And so that's the main principle behind a particle accelerator. You want to accelerate across a potential difference many times. So the simplest one is a linear particle accelerator called a LINAC. LINAC stands for linear accelerator. Okay? And so you basically accelerate in a straight line. So here, now I know this looks complicated, this diagram looks complicated, but it really is not. So as you can see, this tube, and this tube are all connected to the same line of circuit, okay? And this same line is connected to one side of the power supply, okay? This tube, and every other tube like that is connected to this line. As you can see here, it's connected to this line. And this line is connected to this side of the power supply. So each adjacent tube is connected to a different side of the power supply. Okay? So there'll be opposite charges. So this tube will be opposite charge to this tube, okay, because it's connected to a different side of the power supply. So if this is positive, then this is negative. Then this is positive, this is negative, this is positive, and so on, so on, so on, okay? Now, let me just get rid of this. Okay. So, now I knew have my charged particles, okay? And here it says particle beam. Now how do I get a particle beam? How do I get charged particles? Well, there's one way. First, I can have a coil and run a very high current through it, okay? Very high current. Now that will create heat because energy will be transferred to the surroundings. That heats up the surroundings. Heat basically gives energy, heats energy, and so that energy can cause electrons to be released from the atoms, cause electrons to be excited. And so that can ionize the atoms, leaving free electrons. Okay? And that's the particle beam. I'm using electrons here because for protons it's a different process since the protons are bound to the nucleus. Okay? Now I want to accelerate it. So how do I accelerate it? I create an electric field from a potential difference. Now as you can see here, there's a potential difference. This side is plus, this side is minus. So there's a potential difference, but there's a problem here. Okay, actually, right. There's a problem here because we want this to be plus in the beginning, so it actually attracts the electrons, right? Actually attracts the electrons. But once the electrons get to about halfway, then they'll feel the repulsive force from this. They'll feel the repulsive force from the negative charge. And so it will actually end up moving in the opposite direction. There'll be a force in the opposite direction, which will decelerate it, causing to lose speed and energy, which is not what we want. We don't want that to happen. So we need to somehow make this positive. And so that's why we use alternating current. Alternating current basically changes from plus to minus. And so this will change from plus to minus. Okay? And it's built such that it rotates every time the electron is halfway here. Halfway here it rotates. So the electron will keep getting attracted. So it'll end up like this. Later on it'll end up like this. And so when the electron's here, now it'll be repelled by this part, attracted to this part. Move like that. And then we change it again, so it doesn't get repelled by this. Instead it gets attracted by this, and so on, so on, so on, okay? Each time moving across a potential difference equal to the power supply, which is V, for example. Okay, so you're moving across that same potential difference many, many times, so you gain energy many, many times. Okay? So, let me tell you one thing. The electron only accelerates in between tubes. Why? Well, because inside a conductor, there is no electric field. That's just a property of conductors. You can never have electric field inside a conductor. It's a hollow conductor. The charges are evenly distributed on the surface. There's no net electric field, okay? So there's no electric field inside a conductor. So the electric field only exists between these conductors, okay? So the electron is only accelerated between the two tubes. So it's accelerated here, 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 here. It's not accelerated inside the tube. And so we call these tubes drift tubes because the electron just drifts. It doesn't accelerate. Now you might be thinking, why do the tubes get longer? Well, think of it like this. So you have a power supply. Power supply has a fixed frequency, meaning it will oscillate, it will change from plus to minus at a fixed time, right? The time won't change every time. Like, no. Yeah, the time won't change every time. It will stay the same. For example, 2 seconds. 2 seconds is very long. That's just an example, okay? It won't change. Time won't change because it has to occur when the electron is halfway between each tube for it to not get repelled and lose energy and speed. So the frequency is fixed. You can't change the frequency. But the electron gains speed right? As it accelerates, it gains speed. E minus is a symbol for electron. So as it gains speed, even though the frequency is fixed, frequency fixed basically means the time period is fixed, okay? So as it gains speed, in a fixed time, it travels a greater distance. Because it's going faster, right? It's going faster because it gains speed. It's being accelerated. And so in a fixed time, it will travel a greater distance. And so these drift tubes have to be greater distance. Otherwise, the electron will reach one end before the frequency switches, and it'll end up being repelled, end up being slowed down, end up losing energy and being decelerated, okay? That's not what we want. So that's why the drift tubes get longer. So you might be thinking, what are the drawbacks of the system? Well, as you can see, the drift tubes get longer, okay? So the longer the drift tubes, the more material you would need to build a system, the more space you would need, and it would just not be viable because you would need so much material to accelerate it far. So that's why you don't really see linear accelerators anymore. Another drawback is that having long drift tubes, you require the length of the whole thing, the length of the whole system, to be quite long. And the reason that's bad, another reason that's bad, is because the Earth is curved, okay? So if you have the tube curving like this, okay, then you see the electron goes in a straight line. The electron moves so fast, it's not subject to Earth's gravity anymore. It's way faster than gravity, okay? The electron moves so fast, move in a straight line, accelerate in a straight line, it'll just leave the tube because the tube's curving around the Earth. The electron won't just leave, right? It won't even get accelerated anymore. So that's why we can't have a system too long. And so that's why linear accelerators are not really used anymore. Instead, we want to confine the electron to a fixed space, fixed length. And so for that, we use something called a cyclotron, which I will discuss in the next video. So, thank you guys for watching. Hope you enjoyed it. Leave a like if you enjoyed it, and tune in for part 2 on particle accelerators. Goodbye.